Okay, so this problem states that we have two pulleys that are stretched over a frictionless, two boxes that are stretched over a frictionless pulley. And we want to know how fast the second box will take to get to the ground if it starts at an initial height of 140 centimeters above the ground. So right here I drew two free body diagrams showing that you have tension pulling up on the mass 1 and you have the weight acting down, and then when it starts to move it will have the acceleration going this way, the force pulling it that way with the acceleration, which is the M1A. So, and then the same thing on this side but opposite. So you'll still have the tension pulling on it right there because it can only pull because it's a string, and you will have the weight pulling down, but then the acceleration will be going down. So I have right here the initial values for mass 1 is 3.6 kilograms and mass 2 is 9.2 kilograms. So first things first, we need to actually find the acceleration so that we can find the time. So we need to find out the total. So we have the mass 1A and then T positive, but the weight's going down, so minus. It's because it's in opposite direction. And then the M2A right here, and the M2 and then minus T because the T is going in the opposite direction, whereas these two are going in the same direction, so they're both in the same, they're both positive. So to get the formula we're going to need to find out the acceleration, we're going to add both of these together. The T's will cancel out, as you can see. Then we will rearrange these to where it becomes mass 2 grams, mass 2 gravity minus mass 1 gravity equals mass 2 acceleration plus mass 1 acceleration. So what we're going to do here is just some basic math, and we're going to factor out the grams and the acceleration, and then we're going to divide this by this so that it becomes this. So now that we have this, we can actually find out what the acceleration of the formula is, and we'll just substitute these values. We know the acceleration for gravity is 9.8 meters per second squared. So we substitute that in, and then we substitute in our mass 2 minus mass 1, then mass 2 plus mass 1, and that's going to give us 4.2875 meters per second squared. And that's the acceleration. That's how fast that's going to be going up, and that's going to be going down. Now, we're going to use this formula to figure out like this formula is usually used for distance, but we're rearranging this so that we can find out the time, because we know the distance it's going to be traveling to 140 centimeters. So we're substituting in for the x value because we know what the final is, which is 1.4 meters. So we'll have the 0 because that's what it's starting off at. It's starting at rest. Then t, it's just the time, plus half the acceleration times t squared. So we don't know what t is. That's what we're trying to find. So we're going to rearrange for t. So once we rearrange for t, it actually comes out to t squared equals 1.4 times 2 divided by 4.2875 meters per second squared. Now all we have to do is square both of these. That will give us t equals 1.4 meters times 2 divided by 4.2875 meters per second squared. As you can see, these meters are going to cancel out, and the second squared will actually, because it's being squared, it's going to become 1 second, so that will give us t equals 0.81 seconds, and that's how long this will take for this to reach to drop 140 centimeters at the acceleration 4.2875 meters per second squared. And the answer is it takes 0.81 seconds.